Okay. Here we go. Transformation of lines. So today it says linear parent function. Linear parent function. Function means what? Equation. I ask you every day, right? Everybody should know that. An equation. So linear means what? Straight line, right? Parent is going to mean original. Okay, so a straight line, original equation. Okay? So that's going to be y equals x. Okay, so you should have everything that I've written on my paper now. And then we're going to talk about what this means in just a second. Okay, so I've got the equation y equals x. This is on the back. This is the same thing as y equals mx plus b. We're going to talk about why this is the original. All right, what's my m of this?
1.
1. Good. What's the number right in front of x? 1. So my m is 1 over 1. What's my b?
1.
The b on the end, there's not a number, so we say that's 0. Good. Okay, if I was to graph this, I would start in the middle, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, in the opposite way. What? You can just watch for now. Okay? Okay, so this is the original line for linear. Y equals x. There's not a number in front of x. Well, there's 1, but there's not like a 2, a 1/2. Okay, there's not something input there. And there's not a b, right? I mean, there is a b. It's 0, but it's not other than 0. 1, 2, 3, 4, 5. Okay? It hasn't shifted the line up or down. Okay? This is the original parent function. Then we start throwing numbers in there after. We can put a 2 in front of the x. We could put a 2 as the b. So then it moves the line. If the b changes, the y-intercept changes. If the slope changes, the steepness is going to change. Okay, you with me? Okay, so this is the parent function, the original. So what we're going to do today is we're going to give you some new equations that have a different number in front of the x and a different b. And we're going to compare that to the original. Okay, so number 1 says, please stop. Number 1 says, using your calculator, graph y equals x. Okay, so everybody go to your calculator. Turn your calculator on. Go to a new document. So everybody needs to do this with me. And we're going to go to a new graph. So are you all in your calculator? Everybody in the graph?
Yep.
And we're going to input y equals x. Now remember, f of x really means what? Y. So it already says y equal. What's the only thing I need to put? X. And graph it. Okay, that's the original. Okay, y equals x. This is the original line. Now it says for A, input the line y equals negative 2x plus 3 on the same graph in your calculator in the f of 2x. How did the new line transform? Okay, so now I'm going to go back here. Okay, so hit tab. And we're going to put this new equation, negative 2x plus 3, on the same graph. So I hit tab, and then I plugged in negative 2x plus 3. You with me?
Whoa.
Did you get it?
Yep.
Okay, hit enter. Okay, so your calculator should look like this.
What? They make you cross over at 1, 1, 1. 1 dash 1. 1 comma 1. Wait. Ta-da. Look at the calculator on there.
Okay, so when I look at this, there's 2 pieces of information. Listen. Shh. There's 2 pieces of information that I'm looking for. I'm looking to see how did the m change. Pick your head up. Pick your head up. We're not doing that. Take your head off. I'm looking to see how did the M change and how did the B change. Okay, how did slope change? How did my y-intercept change? Okay, so blue is the original. What's different about the red? Okay, it became what? A negative. So the red slope became negative. So that's going to be the first thing I write. So slope became negative. So everybody should have that on their paper. Okay, now look back at your graph. If you were on rollerblades and you were going down the red hill and the blue hill, which one would you go down faster? The red. Why?
Because it's steeper.
Because it's steeper. So my new line, not only is it now negative, it's also steeper, more steep. Okay? So its slope became negative and more steep. Okay? So that's my slope. That's the first thing I'm going to talk about is slope. The second thing I'm going to talk about is the y-intercept. Okay? So I'm going to go back to my graph. Blue line is the original. Here's the y-intercept for the blue line. What happened to the y-intercept for the red line?
The y-intercept went 3 up.
Good. It translated.
To 3.
It shifted 3 units up. Okay, so that's what I'm going to write. Y-intercept. So everybody write that. Y-intercept shifted 3 units. Which way? Up. Good. So you're telling me the slope and the y-intercept, your M and your B. Okay, part B right here. Shh, boys. Part B says, input the line y equals 1/3 x into your calculator under F2 of x. Keep the F1 the same. How did your line transform? So what we're going to do is you're going to keep this in the calculator. Okay? You're keeping this, but you're going to delete this line out and put this one in. Okay, so let's do it together. So hit tab. Come on. Okay, hit tab. We're going to go up, and we're going to delete this out. But we're going to keep the original the same. Y equals x is going to stay. Now I'm going to do 1/3 x minus 3. Hit tab. Got it? Scroll up. Delete that equation. And then plug in this one. Okay? Did you get this? Got it? Get it? Get it? Get it? Did you get it, Kim? Okay. Okay, hit enter. So now your calculator should look like this. 1/3 x minus 3. It's on your paper under part B. Okay, so we're going to talk about the slope first. Did you do 1/3 x minus 3? Okay, go hit tab, go back up, and change it to how it should look. Okay, so let's talk about slope first, and I'm looking at the red line. If you were to rollerblade down the lines, which one would be faster? The blue. So what happened to the red? It is less steep. Okay, so I'm going to put slope became less steep. Did it switch from positive to negative or negative to positive?
Positive to no.
No.
Positive to negative.
They're both what? Positive. They're both going in a positive direction. So I don't need to say anything about the positive or negative because it didn't change. They both stayed positive. Okay? Okay, what about the y-intercept? Blue is the original.
It went 3 units down.
Good. Shifted 3 units down. So tell me that the y-intercept shifted 3 units down. Did y'all get that?
Yeah.
Because you're not writing. You can write as I talk. Okay. Okay. Number 2. 2 says, put the equations y equals negative 3x minus 4 and y equals negative 5x plus 1 into the calculator. How did the line transform? Okay, so this is a new problem, so let's start all the way over in the calculator. So go to the home button this time. And go to a new graph. Add a new graph. So I want to see everybody typing. New graph. All right, let's put the new original. So negative 3x minus 4.
Dang, that's, well.
Okay, so this blue line is now the original. Okay, that's what I'm looking for. I'm looking at this one, comparing. And then I'm going to plug in negative 5x plus 1. So I got to go tab, negative 5x plus 1. I'm putting them on the same graph. Do you have the second line, Leva? Okay, Donovan, you got the second line on there? Brandon, Landon, y'all got the second line?
No. Yeah.
Come on. Okay. All right, there's my new one. Please stop.
Wait, where are yours?
Okay, so what happened to the slope of the red line?
It's a lot steeper.
Good. So the red line, so the slope is more steep. Y'all kind of getting the hang of it? Did it go from positive to negative or from negative to positive?
No.
No, they both are what?
Negative.
They're both negative.
Ew.
Okay, so what happened to the y-intercept? If my original is blue.
It went 5 units up.
Okay, so my original is blue. Good. It went shifted up 1, 2, 3, 4, 5 units. So y-intercept shifted 5 units up. Questions? Anybody? Doing okay? Braxton, you good?
Oh, yeah.
Okay. Now let's look at what we've talked about. We're looking at our M and our B, my slope and my y-intercept. So if you look at example 2, look at the M's, negative 3 and negative 5. Okay, that's what I'm talking about on the graph. How did the slope change? Well, did one go from negative to positive? Did the graph switch? Okay, did it move from negative to positive? Well, look at your slopes here. They're both what? Negative. So they're not going to change on the graph if both slopes in the equation are negative. Okay, look at your B. It went from negative 4 to a positive 1. Listen, your B went from negative 4 to a positive 1. So that tells me that the y-intercept is going to shift positively in the up direction because it went from negative 4 to positive 1. So it's going to shift 5 units up. So before I even graph it on my calculator, I can look at the M and the B in the equation and kind of get an idea of what it's going to look like. Okay? You can get an idea. I still want you to graph it and make sure, but you can kind of know, is it going to go positive to negative? How is it going to be shifting up or down? Okay? So let's look at example 3. Here's the original. And here's the new. So what can I determine before I even graph of how this is going to look? Stop. I'm about to move you again. You are, though. You're being distracting. You're distracting me as a teacher. So you're distracting each other, and now I'm having to take my time out to ask you to stop because you're distracting me. Okay. Okay, so before I even graph it at the calculator, how can I decide that it's going to move? What's going to happen?
It won't.
They're both positive. So
Both slopes are positive, so they're both going to be moving in a positive direction. What else can I determine?
negative 5.
The negative 5. What's that going to tell me?
It's going to move 5 negative. It's going to move 5 down.
Good. The y-intercept is going to shift 5 units down because the y goes from 0 to negative 5. So let's graph these and let's look at them and see if we're right. So go to a new graph because I have a new problem. Come on down there. Okay.
I already did that.
Okay, so my first is y equals x. So all I need to plug in is the x. Graph it. Then I'm going to plug in the second equation. So I'm going to go to tab and plug in 4 over 3. Make sure you're doing this with me. X minus 5. And there it is. Okay, so did they both stay positive like we thought?
Yep.
Yes. But what happened? What else happened to the slope, though?
The new one is more steep.
The new one is more steep. Okay? So the slope is more steep. Okay? What about the y-intercept? It went from 0 and then it went down how many?
5.
5, just like we thought it would. So y-intercept shifted 5 units down. Any questions so far? How are we feeling?
Right.
Okay? Okay, number 4. 4 says, which best describes the effect on the graph of f of x equals negative 3x plus 7 if the y-intercept is changed to negative 5? So what's being changed, my m or my b? The b. So the b is going to be changed to negative 5. What about the m? It's going to stay the same. So what should my new equation look like? Y equals, the m is the same, but my b is changing to negative 5. Okay, let's read the answer choices before we even graph it. A says the slope decreases. Did the slope change? No, the slope stays the same. They're both negative 3. If they're the exact same, does that mean the new one decreased? No. Okay, so nothing happens to the slope. B says the new line passes through the origin.
Nope.
No.
If it goes to the origin, what would have to happen to the equation?
The slope would be x.
The b would be 0.
The b would be 0 if it goes through the origin. Okay, well the b's not 0, so that can't be it. C says the x-intercept increases.
Nope.
No.
How do I know?
Because the x is the same.
That's slope. The slope is the same. Do I know about the x-intercept?
No.
No, I don't know anything about the x-intercept until I graph it.
I got it right
You have to graph it, okay? Hold on. D says the y-intercept decreases.
Yes.
Do I know that? It goes from positive 7 to negative 5. Is that an increase or a decrease? It's a decrease, so D could be right. Okay? Levi, let me see your calculator so I can put it under here. Okay, he's already graphed them, so let's just look at his. It says the x-intercept increases. Well, here's my original, the blue. Does the x-intercept, I'm trying, there it goes. Does the x-intercept increase or decrease if it goes from here to here?
Decrease.
It decreases. Well, the answer choice says increase, so that can't be it either. So the only one that's right is D. Okay, D is the only one that's right. The y-intercept decreases. Okay, questions? Okay, number 5, last one. If the slope of the function y equals negative 4.5x plus 3.2 is changed to 1.5, Which of the following best describes the graph of the new function? Okay, so now what's changing?
The slope.
The slope. Okay, so y equals, my new slope is 1.5x. Does the y-intercept change?
No.
No. So plus 3.2. All right, let's read our answer choices. A, the new graph of the function intercepts the y-axis at the same point as the original function. Do they have the same intercept on the y-axis?
Yes.
Do they have the same b? Yes, so that works. B, the graph of the new function intercepts the x-axis at the same point. Do I know anything about the x-axis? Not yet. C, the graph of the new function has a negative slope. Well, does my new equation have a negative slope?
No.
No, it's positive, so that can't be it. D, the graph of the new function has a positive x-intercept. Do I know anything about the x-intercept yet?
No.
No, you have to graph it. Okay, so let's look at the graph. That's not right. You forgot your x. Okay, you forgot your x.
Yeah, I did.
Okay, so here we go. Y equals negative 4.5x plus 3.2. So there's the original. And here's the new. 1.5x plus 3.2.
That's right. There it is.
Okay, so A says the new function, they have the same y-intercept. Do they have the same y-intercept?
No.
Yes, they do. They both cross the y-axis at the same spot. B says the graph of the new function intercepts the x-axis at the same point. Do they have the same x-intercept?
No.
Nope. D, the graph of the new function has a positive x-intercept. Here's the new function, the red. Does it have a positive x-intercept? Nope, it's negative. So the answer is A. Okay, any
Now
questions?
That's pretty simple.
Yes, it is. It just takes a little bit of time to graph. Okay, any questions?
No.